In this video, I'm going to introduce the convolution of two functions, which is a way to combine two new functions to get a new function. So let me just go on ahead and tell you what it is. So let f and g be two functions that have Laplace transforms, and as usual, f of s is going to note the Laplace transform of f, and g of s is going to denote the Laplace transform of g. Then we have the following theorem. If I look at the product, big F times big G, this is the Laplace transform of the following function, h of t, which is defined as an integral. It's the integral from tau equals 0 to t, f of t minus tau, g of tau, d tau, and by a change of variables, this is equal to the integral tau equals 0 to t, g of t minus tau, f of tau, d tau. Part of the theorem is that these two integrals are equal to each other. It involves a change of variables. We're going to look at it a little bit later in more detail, but for now, suffice it to say that if you say u is equal to t minus tau, and then make the typical changes that you would do when doing u substitution, you can see that these two integrals are equal. And this, so each one of these has a special name. So the integral tau equals 0 to t, f of t minus tau, g of tau, d tau. This is the definition of the convolution f convolved with g. Okay, so in other words, it takes two functions, f and g, and spits out a brand new function. Just like multiplication. Multiplication, you multiply two things, two functions, two numbers, whatever, and you get a new number. Convolution, you take two functions, you convolve them, and you get a new function, and this is just the definition of that convolution. And there's sort of a symmetric definition, or a symmetric convolution. The integral from tau equals 0 to t, g of t minus tau, f of tau, d tau. This defines the convolution of g with f. So this is g convolved with f of t. Okay, of course, what I'm asserting up here with this is that both of these two things are equal. We haven't proven that yet, but I will prove it, and I will prove this theorem. So another way to write this theorem here, that I said here is that the Laplace transform of f convolved with g is equal to the Laplace transform of f times the Laplace transform of g. Okay, now convolution, as I said, convolution is very similar to multiplication, and it has some similar properties. And I will prove these properties in either the next video or the video after this. The first property is the following. It's one we've already stated, that f star g is equal to g star f. So sometimes I might say f star g, sometimes I might say f convolved with g. All means the same thing. Okay, so there's a sort of commutativity. There's a kind of distributive property. So f convolved with g1 plus g2 is equal to f convolved with g1 plus f convolved with g2. Then f convolved with g convolved with h. Now there's two convolutions. This is a kind of associative property. This is equal to f convolved with g convolved with h. Okay, so these are three properties, and one that I didn't sort of went down here to the next line is f convolved with 0 is equal to 0. So when you convolve f with 0, it's just equal to 0. Okay, so these are all very similar to multiplication properties, but there is one important multiplication property that convolution does not have, and that is the following. F convolved with 1 is not equal to f. Okay, so if convolution acted a lot like multiplication, we would expect this identity hold. But as a matter of fact, this identity does not hold. And you can see that for a number of reasons. If you just pick some function f and do the convolution of f with 1, you'll see it's not equal to f. So for example, if f of t is equal to e to the t, then the convolution f convolved with 1 of t is going to be the integral tau equals 0 to t e to the t minus tau times 1 d tau. And this, so remember, as far as the integral is concerned, t is a constant. So this is e to the t times the integral tau equals 0 to t e to the minus tau d tau. And this is equal to e to the t times the integral. So the antiderivative of e to the minus tau is minus e to the minus tau. So this is e to the 0 minus e to the minus t. Or what's going to happen, this is going to be e to the t minus 1. And this is definitely not equal to e to the t. Okay, so this just gives one example showing that f convolved with 1 is not equal to f. So in other words, we do not have one of the identities we want. One of the identities we would want would be for there to be f convolved with 1 is equal to f. But for now, that's all I want to say about convolution, just sort of a definition and some general properties about it.